Good day. Yep, this is RG Malandog, and I will report Chapter 3 of Advanced Production and Operation Management, which is workload assessment or forecasting. So, forecasting is an estimate of demand which will happen in the future. Forecasting is not the term generally used to talk about the composition of a random draw of cards or how a roulette wheel performs. Those are statistical phenomena for which probabilities are known. So forecasting is that foretells sales demand volume even though the probabilities have never been formally studied. Business people often use their sense of what is happening to reach decisions that might be better made if someone had kept a record of what had taken place already. So there is often some empirical basis for estimating what is likely to happen in the future. Forecast of demands volumes market shares, and revenues difficult but not irrational. One of the best sources of information about the future is the past. For new products, there is no past, and so other methods can be tried. Since it is only an estimate based on the past demand, proper care must be taken while estimating it. Given the sales forecast, the factory capacity, the aggregate inventory levels, and size of the workforce, the manager must decide at what rate of production to operate the plant over an immediate planning horizon. So the focus here is on using existing data to develop forecasts. Mathematical equations are used for various kinds of forecasting. It is important to stress that equations do not make forecasts the truth. Also, a great deal of good forecasting can be done without mathematics. And further, which or without mathematics, no forecast is ever guaranteed. A time series is a stream of data that represents the past measurements. Each event or observation of demand is time tagged so that it is known where it is located in the series of data. The time series consists of data recorded at different times periods such as weekly or daily for the variable, which could be unit produced or demands received. Time in time series analysis, external causes are not brought into the picture. So the pattern of the series is considered to be time dependent. So the data in time series may consist of several different kinds of variations. So important among them are random variations, an increasing or decreasing trend, and seasonal variation. So random variation occurs because the demand is seldom constant at a given level. So the random variations are a result of the economic environment and the marketplace within which an organization is operating. In addition to random variations, the time series data may exhibit an increasing or decreasing trend. In such cases, it is possible to extrapolate the curve by eye, but the rate of change can be calculated and projections can be made mathematically. In mathematics, extrapolation is the extension of a graph, curve, or range of values by inferring unknown values from trends in the known data. So the time series may also exhibit seasonal or cyclical variations. So the graph on the left shows seasonal variations coupled with random variations, whereas the graph on the right combines all three components random variations, an increasing trend, and seasonal variation. For example, one may observe seasonal variations in demand for resorts, hotel, and home heating oil. So, time series analysis is analysis of any variable classified by time in which the values of the variables are functions of the time periods. So, time series data can be reflect erratic bursts called impulses. If these spikes appear from time to time and some pattern can be associated with them, they could be added to the list of what can be extrapolated or projected into the future. Time series analysis deals with using knowledge about cycles, trends, and averages to forecast future events. It is always useful to try to find causal links between well-known cycles such as the seasons and demands patterns that are being tracked. Time series analysis use statistical methods, including trends and cycles analysis, to predict future values based on the history of sales or whatever the time series describes. The importance of time series analysis is it helps organizations understand the underlying causes of trends or systematic patterns over time. Using data visualizations, business users can see seasonal trends and dig deeper into why these trends occur. It is also used to determine a good model that can be used to forecast business metrics such as stock, market price, sales, turnover, and more. It also allows management to understand timely patterns in data and analyze trend in business metrics. Forecasting methods for time series analysis. So we will study the following techniques from time series analysis: moving average, weighted moving average, exponential smoothing, seasonal forecasting, and trend analysis. So the moving average or MA method supplies a forecast of future values based on recent past history. MA is also called simple MA method. So the latest N consecutive values, which are observations of actual events such as daily, weekly, monthly, or yearly demand, are used in making a forecast. These data are recorded and must be updated to maintain the most recent N values. With the passing of each time period, the most recent value is stored and the value of the earliest period is dropped off. For example, if you want to forecast demand for April using n is equals to 3, then the demands for last 3 months, that is January, February, and March, are needed. So the forecast for April can be calculated as forecast for April is equals to the summation of January demand, February demand, March demand all over 3. So consider the demand or data given in this table: 10 periods. So the forecast for months 4 to 10 is given in the table. So the number used in the formula for each month are given in the calculation column. In general, an n month moving average is the sum of the observed values during the past n months divided by n. So moving average might be used to extrapolate next event if the following occurs. There is no discernible cyclical pattern, and the system appears to be generating a series of values such that the last set of values provides the best estimate of what will be the next value. Weighted moving average, a way to make forecasts more responsive to the most recent actual occurrence or demand, is to use the weighted moving average or WMA method. Just like the MA method, the most recent end period is used in forecasting. However, each period is assigned a weight between 0 and 1. So the total of all weights add up to 1. So the highest weight is assigned to the most recent period, and then the weights are assigned to the previous periods in the descending order of magnitude. So for example, consider the data given in this table. Suppose the number of periods used in forecasting is n is equals to 3, and the weights are zero, zero point 0.2, zero point 0.3, and zero point 0.5. So the highest weight, in this case is zero point 0.5, is assigned to the most recent period. So for example, the forecast for period 4 will be calculated by using the weight zero point 0.5 period for period 3, zero point 0.3 for period 2, and zero point 0.02 for period 1. So the forecast for period 4 will then be demand zero point 0.5 times demand 1 plus zero point 0.3 times demand 2 plus zero point 0.5 times demand 3. So the WMA method allows the latest period to have the greatest impact and the later periods decreasing importance. So note that when all weights are equal to 1, the WMA is the same as MA. So the biggest weights are assigned to the most recent events when there is a continuing trend. The exponential smoothing or the ES method, like the WMA method, calculates an average demand or forecast. So ES methodology remembers the last estimate of the average value of demand and combines it with the most recent observed actual value to form a new estimated average. So ES forecasts the demands for a given period T by combining the forecast of the previous period T minus 1 and the actual demand of the previous period T minus 1. So the actual demand for the previous period is given a weight of alpha, and the forecast of the prior period is given a weight of 1 minus alpha, where alpha is a smoothing constant whose value lies between 0 and 1. So the equation for the forecast for the period T is forecast T is equals to forecast T minus 1 plus alpha times actual demand T minus 1 minus forecast T minus 1, wherein alpha is greater than or equal to 0 but less than or equal to 1. So for example, consider the data given in the table. So the ES method makes a forecast starting from period 2. So the forecast for the first period is generally set equal to the actual demand in that period to get the forecasting process started. So forecasts for all periods 2 is equals to 10 are given in the table. So ES is a simpler method requiring fewer calculation than WMA, which needs n weights and n periods of data for each forecast estimate. So ES needs only three pieces of data. Also, it can be more effective because only one weight or alpha has to be chosen. This makes it easier to experiment with past data to see which value of alpha provides the least forecast error. Often, the use of the ES method for forecasting is referred to the WMA method. So the ES method has a clear advantage over the MA method in terms of the amount of memory required for storing the data. In addition to the smoothing constant alpha, at any time, we need to store only the exponentially smoothed average and the actual demand for the previous period. So for the MA method, actual demands for the last n periods have to be restored. Forecasting with a seasonal style. So forecasting when seasonality is present can be done by assuming that what happened last year or last month will happen again. So we call it the historical forecast method. So the pattern is expected to repeat itself within the time period. So this method works if a stable pattern, which is often seasonal, exists. The hotel and resort business are typically involved with historical forecast, as is the agriculture business. When last year's monthly sales values are used to predict the next year's monthly sales values, the method is based on using past history to forecast. The same concept applies to weekly or daily sales, which can be forecast on a semi annual, quarterly, or monthly basis. It shows in this table the historical forecast technique applies to data that exhibits a seasonal cycle. So no modification has been made for an overall change in annual sales, which is the basis of the historical forecast. So consider the data in the table that gives the quarterly demand for last 4 years. There is a clear pattern of demand variation among the 4 quarters. Based on this data, we can forecast the demand for the 4 quarters of year 5. Assume that the annual demand is expected to be 2,800 in year 5. So this demand has to be estimated using other techniques. So the following 5 steps process will be used to obtain the quarterly demand. So step 1, find average quarterly demand for each year. So the total demand for each year is divided by 4 number of quarters in each year to obtain the average demand in each year. So the table gives the average demand for each quarter. Step 2, compute seasonal index or SI for each quarter for each year. So the seasonal index for a quarter for a given year is obtained by dividing the demand in that quarter by the average quarterly demand for that year. For example, the seasonal index for the winter quarter of year 2 is 1.09, which is obtained by dividing 2,420, which is the demand for the winter quarter in year 2, by 2,221, which is the average quarterly demand for year 2. So the seasonal indices for each quarter of each year are given in this table. The formula to calculate the seasonal indices are also given in this table. Step 3, calculate the average SI for each year or for each quarter. So the next step is to find the average seasonal index for each quarter, which is simply the average of the seasonal indices calculated in step 2. So this table gives the average seasonal index for each quarter. Step 4, calculate the average quarterly demand for next year. In this step, we will find the average quarterly demand for the next year. The yearly demand estimate for next year is 2,800. Therefore, the average quarterly demand is equal to 2,800 divided by 4, which is 700. This step is shown in this table. Step 5, forecast demand for quarters of next year. So the quarterly demand for each quarter of next year is obtained by multiplying the average demand by the SI for each quarter. This table gives the forecast of the quarterly demand of next year. For example, forecast for the spring quarter is equals to 638, which is 700 times 0.912, where 700 is the average quarterly demand and 0.912 is the average SI for the spring quarter. In our example, we have used year as the time period in which the seasons are represented by quarters. So the seasons could have been represented by months if the time series shows variation by month. In some instances, the week could be the time period and the days could be the seasons if the demand fluctuates on a daily basis. Restaurants and are good example of where the demand fluctuates on a daily basis. Even hour of the day can be the season if the demand fluctuates hourly in a given day. For example, the power generation requirement in a power utility or the number of calls in a telephone company vary on an hourly basis. So trend analysis, if the time series exhibits an increasing or decreasing trend, then the techniques discussed above, which is MA, WMA, and ES, may not be appropriate for making a forecast. So we perform a trend analysis to make a forecast in this case. Consider this graph. The zigzag line shows the demand for 10 periods. There's clearly an increasing trend, so the trend will fit a trend line through this data to make forecasts. So the equation of the trend line is y is equal to a plus bx, where y is the demand forecast and x is the time period. So x is the independent variable and y is the dependent variable since the demand depends on the time period. As x increases, y increases in an increasing trend. Y will decrease as x increases in a decreasing trend. In the trend line equation, a is the intercept on the y-axis, which is the value of the demand, y, where x is equal to 0. The slope of the line is represented by b, which gives the change in the value of demand, variation y, for a unit change in the value of x. That is, b is the amount by which demand will change if the time period changes by 1. So there are mathematical formulas for finding the values of a and b. Excel computer program has built-in functions to find the value of a and b. The intercept function in Excel calculates a, and the slope function is used to find the value of b. Excel functions are employed in this text to find the value of a and b. Example, consider the demand data for 10 periods given in this table. The Excel function gives b is equals to 8.65 and a is equal to 2.73. So the forecast can now be made for any time period using these numbers. For example, using the slope intercept formula y is equals to a plus bx, the forecast for period 11, which is x is equal to 11, will be f of 11 is equal to 2.73 plus the product of 11 and 8.65, which will give us figure of 97.87. So similarly, the forecast for period 12 will be f is equal to 12, f to f of 12 is equal to 2.73 plus the product of 12 and 8.65, which will give us a figure of 106.52. So the forecast can be made for any future period. So another valuable method that assists forecasting is regression analysis. This method is useful for establishing a relationship between two sets of numbers that are time series. For example, when a series of y numbers, such as the monthly sales of camera over a period of years, is cash causally connected to the series of X numbers, which is the monthly advertising budget, then it is beneficial to establish a relationship between X and Y in order to forecast Y. So the first assumption that is generally made in regression analysis is that the relationship between the correlate pairs is linear. It is the easiest assumption to check. However, if nonlinear relations are hypothesized, there are strong but more complex method for doing linear regression analysis. In regression analysis, x is the independent variable and y is the dependent variable. Example, consider the data given in this table. This table gives 10 observations for the values of x, which is independent variable, and the corresponding values of y, which is the dependent variable. The data are plotted in the graph. We can fit a straight line called the regression line to this data. So this line will be estimated of the way in which the value of x affects the value of y. For example, a linear trend is assumed. Once the line is determined, it can be used to extrapolate future demands or the value of y. So the equation of the regression line is y is equal to a plus bx. As in trend analysis, a is the intercept on the y-axis, which is the value of the demand when x is equal to 0. So the slope of the line is represented by b, which gives the change in the value of demand y for a unit change in the value of x. That is, b is the amount by which the demand will change if the independent variable change by 1 unit. We can use the Excel program's built-in function to find the values of a and b. So the Excel function gives a is equal to 62.44 and b is equal to 50.23. So a forecast can now be made for any value of x. Suppose that x is equal to 15, then the forecast will be y is equal to 62.44 plus the product of 50.23 times 15, which will give us a figure of 815.84. So coefficients of correlation and determination. So an important prerequisite to use regression analysis is the existence of a causal relationship between x and y. Therefore, before we even determine the regression analysis or the regression equation, it is important to find out whether there exists a relationship between x and y. So the scatter diagrams visually display the relationship between x and y. So scatter diagrams are useful visual aids to find whether there is a relationship between x and y. These relationships can also be established in quantitative terms by calculating the correlation coefficient. So a correlation coefficient R shows the extent of correlation of x and y, where R can take on values from -1 to +1. At -1, x and y are perfectly correlated, going in opposite directions. As x gets large, y gets small, and vice versa. When r is equal to 0, there is no correlation where r plus and when r is equal to +1, x and y are perfectly correlated, going in the same direction. It is not only the relationship that exists between x and y before doing the regression analysis, but it is important that a causal relationship also exists between the dependent x and the dependent y variables, meaning change in y can be explained due to the change in x. A causal factor that is common to both x and y and which operates as an unknown link may be responsible for whatever relationship is found between x and y. When a series of x numbers is causally connected with a series of y numbers, then it is beneficial to collect the information about x in order to forecast y. Often by chance, correlation appears to be strong, although the relationship is purely random. So the coefficient of determination R2 is a measure of the variability that is accounted by the regression line for the dependent variable. So the coefficient of determination always falls between 0 and 1. For example, if r is equals to zero point 0.8, the coefficient of determination R2 or R squared is equals to 0.64, meaning that 64% of the variation in y is due to variation in x. The remaining 36% variation in the value of y is due to other variables. So forecasting errors. It is very rare to get 100% accurate forecast. There are always some errors in forecasting. So a good forecasting technique tries to minimize the errors. So the forecasting errors are computed by comparing the actual demand for time period t with the forecast for the same period. That is, error t is equal to demand t minus forecast t. So two kinds of forecasting errors can occur. First, actual demand is greater than the forecast. This is a forecasting underestimate. By convention, when actual demand is greater than forecast, the error term is positive. Second, actual demand is less than the forecast. This is a forecasting overestimate, and in this case, the error is negative. So, to choose a forecasting method, it is necessary to be able to compare the errors that each method generates for particular circumstances. There are several different ways of measuring errors. The choice is dependent on the situation and what kind of comparison is wanted. Thus, absolute measures are used to count all errors conservatively. Absolute measures mean that positive and negative errors are treated the same way. So the reason for doing this is to prevent positive and negative errors from canceling each other out. We will study a most commonly used method that calculates mean absolute deviation or MAD of the error terms. To calculate MAD, take the sum of the absolute measures of the error and divide that sum by the numbers of observations. So MAD treats all errors linearly and is a more conservative measure. Example, consider the data given in this table. So the demand and forecast are given for 10 periods in column 2 and 3. So column 4 gives the error for each period and column 5 gives the absolute error. So the sum of the absolute error for 10 periods is 171. Therefore, MAD is equal to 171 divided by 10, which will give us figure of 17.10. So to select a particular forecast method, say ES, we will calculate the values of MAD by using different values of alpha. So the value of alpha that minimizes MAD will be selected. Similarly, applies to the MA method, we will calculate MAD for the different values of N. So the N that minimizes MAD will be selected. A similar procedure will be used with the WMA method to find the best combination of weights. So the Delphi method. Delphi is a forecasting method that relies on experts' estimate of future events. In one of its forms, the experts submit their opinions to a single individual who is the only one that knows who the participants are and what they have to say. So the person who is the Delphi manager combines the opinions into a report, which, while protecting anonymity, is then disseminated to all participants. The participants are asked whether they wish to reevaluate and alter their previous opinions in the face of the body of opinion of their colleagues. Gradually, the group is supposed to move towards consensus. If it does not, at the least, a set of different possibilities can be presented to management. In a nutshell, Delphi method is a survey-based framework for estimating the likelihood and outcome of future events. There is no evidence that the Delphi method provides forecasts with smaller errors than other techniques. It is apparent that managers gain greater perspective about forces that should be considered when they are contemplating possible outcomes. That is a positive benefit of Delphi. So pooling information and forecast. Methods for pooling information to provide stronger forecasts should be explored. It is critically it is critical that all parties share their forecasts as much as possible and try to find ways to combine them. Usually, stronger forecasts can be obtained if both data and experience are pooled. One of the keys to success in combining forecasts is a trial and error. What seems to work is retained and what fails is discarded. As an example of pooling, the results of a regression analysis could be augmented by a Delphi type estimation. In this way, experience and data analysis might be combined to provide a stronger conclusions. Formal method can be used to evaluate how well different forecasting techniques are doing. At each period, the method that did best the last time is chosen for the forecast that will be followed. So forecasts are still derived from the alternative methods, but they are recorded and not followed. When the actual demand results are unknown, the various forecasting methods are evaluated again, and the one that is most successful is chosen to make the prediction for the next period. Averaging of forecast results also is used. So the results of taking forecasts from more than one method and averaging these results to predict demand has been successful in circumstances where choosing the best method produces frequent alteration of the chosen method. Product life cycle stages and forecasting. Throughout the company, the planning function marches to the drumbeat of product lifecycle stages. Operations managers need to be aware of the timing and stages that drives the development schedules of new product. goods and services, as well as the product and delivery schedules of the company's mature products. So the product life cycles are composed of four stages that appear in a regular way over time. All products and service go through the following stages: introduction to the market, growth of volume and share, maturation, where maturity is the phase of relative equilibrium, decline occurs because of deteriorating sales, decline leads to restaging or withdrawal. Introduction and growth of the new product, goods and services. There are two new products early phases of life cycle stages. These are initial introduction and sales growth of the product. So the idea for the product and its development precedes the introduction. The entire team works on the ascertaining the marketing feasibility of the idea, as well as the feasibility of making it and delivering it. Research and development may have made sample product so that market research can test its customers' acceptability. When it is approved, the production and operation management and engineering swing into action to create the production system that can make and or assemble it. During this process, during this process of bringing the idea to reality, there are many makes or buy analysis. So maturation and decline of the new product, goods and services. When the new product or service stops growing, it is considered mature. This means that its volume is stabilized and the saturation level for that brand. The competitors have divided the market, and only extraordinary events such as a strike at a competitor's plant are able to shift shares and volumes. During the introductory phase, marketing takes specific actions during this phase to maintain the product shares of the market. Prices often are lowered. Coordination between production and operation management and sales is essential to meet delivery schedules on time. Finally, the product begins to lose share, volume drops, and depending on the strategy, the product is either restaged or terminated. So demand prediction in life cycle stages. So life cycle stages provide a classification for understanding the kind of trends that can be expected in demand. During the introduction, the demand is led by the desire to fill the pipeline. This means getting product into the stores or into warehouses, or whether it must be to supply to customers. When growth starts to occur, there is a trend line of increasing sales. The trick is to estimate how fast demand will increase over time and for how long a period growth will continue. There are good methods used by market research to find out what is happening. This information is fed back through the sales to production and operation management for purposes of production scheduling. The challenge for production and operation management is the rapidity of adjustment that is required to all of the life cycle stages changes and to go through them frequently, that is plant expansion and contraction, new supply chain sources, inventory obsoleted by immediate demands for new products, so example of which is mobile phone. So protection of established or mature products, goods and services. Organizations that have been successful with their new product introductions can bank on having established products or service that generate cash flow. So the bank is not as good as it is used to be though, because the competitive rate of new product introductions has increased markedly in recent years. So production and operation management requires the cash to pay labor and buy materials from suppliers. So generally, the production and operation management spends more cash than any other department in the company. This cash accounts for operating expenses may total 70% of all cash spent by the company. So to meet the cash flow requirements and to have the right plans in place requirements excellent forecasting abilities of the marketplace dynamics. So this is the phase where many big companies fail to forecast changes and they lose their edge or went bankrupt. Example include Sony Betamax, Blockbuster, Borders, Circuit City, Digital Equipment, Eastman Kodak, and so on. So each and and every one of these situations might have been avoided if forecasting had called attention to the cliff that was in front of their fast moving trajectory. So, to summarize, strategic planning requires teamwork, and production and operation management should be part of the team. So this chapter discusses production and operation management's role in helping to develop strategies and illuminates production operation management's assignment to carry them out. So production and operation management is responsible for seeking out and adopting best practices. So life cycle stages are developed. This includes introduction and growth of new products, following followed by their maturation and decline. So, production and operation management is expected to protect established products. So, the challenge is difficult when competitors introduce disruptive innovations. So, recognitions of problems and fast action to deal with disruptions are needed. So, forecasting is essential for proper management of life cycle stages. Extrapolation and correlation are vital method used with time series analysis. Other important forecasting methods that are covered including moving average method, weighted moving average method, regression analysis, correlation coefficients, coefficients of determination, multiple forecast, and the Delphi method. Also, the means of for evaluating the different forecasting method are by comparing the kind of errors they generate is also covered. And that's the end of my video. Thank you for watching.